Today we will see the introduction to clustering. This is a big question. What is meant by the clustering and where it is applicable in the machine learning? And what is the area, what is the space where the clustering is applicable in the machine learning approaches? And that part we were to start with the simple way in form of the its two flavor of the clustering. One is a hierarchical and other one is a partition clustering. Let me show the first this diagram. This diagram is required to show the complete picture what we have covered so far. As we know in the machine learning, we have a three kind of the flavor. One is supervised, unsupervised, and reinforcement learning. If talking about the data type, that is a continuous and categorical. So in the supervised learning, we have covered or we have seen with the practical numerical as well, regression, linear regression, polynomial regression, multiple linear regression, descent tree, random forest classifier, along with the database classifier. So where we have used the data type or data nature in form of the continuous. But when talking about the classification concept, that we have the use the data in the category. So KNN, that is a k-nearest neighbor algorithm. We have seen descent tree classifier. We have also covered. If you have remembered the some example of the logistic regression, then we have covered this regression under into the classification. Naive-Bayes classification is not part of the syllabus, so we have not touched, but if time permits, definitely we will see this classification as well. Or if time is not permitting to us, if you need, then I will share the notes and other material on the Naive-Bayes classification if you need. Next one, we have seen the SVM. So the practical part in the SVM, that is support vector machine, we have seen through the SVC class in the Python programming, that is the support vector classifier. So for using the classification, we have used the categorical nature of the data. But if you talk about the supervised learning, then we have seen this all these various methods or approaches in the supervised learning. So far we have covered as per the curriculum or syllabus. But when talking about the unsupervised learning, so in the unsupervised learning, we have a various flavors of the unsupervised learning. One is clustering and association analysis, the hidden Markov model. When talking about the clustering, so for applying the clustering, we need the continuous nature of the data. And in this case, we have the three different algorithms. One is the SPT, PCA, and K-means. As per the syllabus or curriculum, we would like to focus on the K-means. So before discussing the K-means clustering algorithm, I would like to introduce the clustering with the basic. Without knowing all these things, you can't understand where K-means is applicable. So where K-means algorithm is lying. So this is the point we need to understand the introduction to clustering. So that's why today's topics or today's lecture name I have given, that is the introduction to clustering. Let us talk about the association mining. So association mining is basically a type of the unsupervised learning where we have to analyze some association between some objects. So a priori algorithm FP growth, that is a feature point growth algorithm, we will see in that part. But I'm truly speaking, and we have to see this one right now. Association mining and hidden Markov are the two different types of the unsupervised learning models where categorical data is required. But please keep in mind, these two models are not mentioned in our syllabus, so we will not touch. We will try to cover all the content, all the important topics which are the part of our syllabus, and if time permits, then I will discuss other topics later. But okay, this is the point you people are required to keep in mind. Now, next one we have the reinforcement learning. So reinforcement learning we will see in detailed way as per the curriculum what are the various methods are given. So supervised learning we have covered. Now let us come to the unsupervised learning. So in the unsupervised learning we have a clustering. So from this point we have a very big question, as I asked a few seconds ago. What is a cluster? A cluster refers to a small group of objects, and clustering is grouping those objects into the cluster. And in order to learn clustering, it is important to understand the scenarios that lead to cluster different objects. So here cluster means we are talking about the groups. So we need to make a group of the same or different type of the data items which are following the same feature similarity. I would like to take the very simple example of your class or students class, we can say. Suppose some students or 50 students are sitting in a class. So I need to divide the two groups of the students. So what is the parameter I can take? I can take the gender feature. Based on the gender feature, I can make the two clusters. One cluster belong to the male cluster, other cluster belong to the female cluster. And this is what? This is the our two groups we have based on the gender feature. So the male person, the male people, they are having the same kind of the gender. It means what we are talking about the based on the similarity features. We are dividing the or we are separating the our or we are creating the two different clusters. Same thing we can happen in the our vegetable shop. Whenever I need to purchase a vegetable from the vegetable shop, then what I have to I have been observed there are many groups or there are many clusters are available in front of the vegetable shops. What are those? The group of the potato, a group of the tomato, and group of the some fruits if it is possible, and there are some different kinds of vegetables are put it by the vegetable shopkeeper in front of the customers in form of the clusters. So why all these things are not mixed up? So customer can easily choose the appropriate cluster or appropriate data item from the same kind of thing. So this is a really thing. This is the real kind of a thing we can see in the real life application. So this is a cluster. So cluster we have seen in the simple way. But in terms of the machine learning, what is a cluster? That is a big question. So we have been observed many things. So what we have the definition of the clustering. So what is clustering actually? This is the big question a student can ask me. Clustering is dividing data points into the homogeneous classes or clusters. That is the point. So clustering is dividing data points into the homogeneous classes or cluster. It means we have many data points in form of the data set. So very book pool we have of the data set where we have to choose the data. Is this data belong to this class or not? So there is some algorithm, there are some steps by which we can easily distinguish all the things. But what is the clustering? So in the clustering, we'll keep in mind some underlying point that the homogeneous. So I can mix up the tomato and potato. If I need to make the cluster, then I have to separate the tomato from the potato or potato from the tomato. So this is what I need to make the same kind of the vegetable in a basket or in a group. This is known as the clustering, and that is a real application we have been observed. So points or data points we're talking about that should be belong to the same group as similar as possible. But the point we have to keep in mind, and the reverse point we can understand the data point are should be or they should be a different group as dissimilar as possible. So you can't uh, put the some boys into the girls group. You can't put the some girls into the boys group. So because we can't say this is a mixed kind of data, we have to follow the homogeneous nature of data rather than the heterogeneous nature of data. So you can't mix up the thing because you have to distinguish the both gender-based people. So that is only meaning. So this is what is a clustering. And when collection of the objects is given, we put object into the based on the similarity, group based on the similarity. And here we are talking about the feature similarity. So suppose I'm very taking simple example. Suppose in the 20 MIM students are there. Now 20 BCY students we have, 20 BI students we have. So how I can differentiate this student belong to 20 MIM, this student belong to 20 BCY, 20 BI? Why? Based on their roll number, based on their subject chosen. So what are the feature I'm putting? Here I'm just putting the what are the courses they have been opted in this semester. So based on their courses opting, I can distinguish, or based on their roll number, I can distinguish this student belong to the 20 MM, this student belong to the 20 BCY, and this student belong to the 20 BAI. So what is this? This is a different kind of the cluster, different kind of the list of the student I can prepare for examination purpose and other purpose as well. So this is the simple exam definition of the clustering. Now it is clear right now. This is the introductory part of the cluster I am discussing right now. Yes, tell me, is it clear?
Yes, sir.
Okay. So the student asked me a question, sir. If you're talking about the clustering, so is there any algorithm of the clustering we can do? Yes, of course, we have many algorithms based on the it's a type of the clustering, we will see. But the student can ask me a question, sir, what is the clustering algorithm? So clustering algorithm is just nothing which is used to analyze the some natural group of data on the basis of the some similarity. It locates the center of the group of the data points, and to carry out effective clustering, the algorithm evaluates the distance between the each point from the centroid of the cluster. Mathematically, can anyone tell me right now what is mean by the centroid? If you remember this word in the geometry, you have seen the what is mean by the centroid. Can anyone tell me right now what is mean by the centroid? If you have any idea about the centroid word in the geometry.
Sir, I think maybe the center of mass for any object.
Okay, great point. I got it. Centroid is basically, generally we can say, centroid is a center point of the our cluster, and from the our cluster we will try to find the distance from the centroid data point to the all the data points, and then we have to decide this data point belong to the this group or this cluster or other group or other cluster based on the distance, and distance we can calculate it by the our equivalent distance. That is a simple concept. So equivalent distance calculation we have seen the Kenan algorithm. So that is the only meaning. So what is a clustering algorithm? Clustering algorithm is just nothing which is a simple algorithm which is used to define the cluster by defining the center and its distance from the center to the all the data point, all the existing data point. Then we will see we got the thing. But before defining the cluster, we don't know the given data or given data points will be the this X cluster or Y cluster or maybe the Z cluster. So that's why all data points will be coming to the unlabeled data. It means we are talking about the unlabeled data, and unsupervised learning, we will use the unlabeled data rather than the labeled data. That is a big point we have to understand. So students are sitting in a class, and but I am taking the example of the unlabeled data, then you can easily understand. I have the class. In my class, MIU student will be there, BCY student will be there, and BI student will be there. They don't know which group they will be a part. So based on their roll number, I can make the cluster, or based on their gender, I can distinguish the students, because they don't know in which group they will be or in which cluster they will be the part. So here I am choosing the gender. So if I'm choosing this gender feature, so some students will be the MI, some student will be the BCY, and some student will be the BI, and those could be the male and female. This is my two cluster I can create based on the gender. But if I'm creating the class group, so I have to make the three different group. One group belong to the MIM, other group belong to the BCY, and other group belong to the BI. So this is the point. Before creating the cluster, before defining the cluster, we don't know the such data points belong to the X cluster, Y cluster, or Z cluster. So there, that's why this label or this unlabeled information or unlabeled data is coming to the unlabeled data. That is only meaning, because unsupervised learning we are following. And raw data we have, and clustering algorithm we have to apply, and then we will make the or we will define the clusters of the data. And that is the functionality of the clustering algorithm we will see. And as far as the centroid is concerned, so I will tell you the centroid meaning. A centroid is the center point of the object. This is a slide which compromising by the geometrical concepts over here. You can see observe here. So data point in which the three medians of the triangle intersect is known as the centroid of the triangle. So if we need to find the center of our object, here we're trying to find the center of our triangle. So we can easily say that the point in which the three medians of the triangle intersect is known as our center of the triangle. And it is also defined as a point of the intersection of all the three medians. And the median is nothing which is just line that join the midpoint on the side and the opposite vertex of the triangle. So you can see from each and every direction, from each and every axis, we can see which is the center point. So as per the definition of the center of the triangle, we can find the centroid point, and that center point is under coming to the our centroid. So this is nothing which is just simple example. And in generally, normally English speaking, we can say centroid is just center point of the our object, and the object could be anything: rectangle, triangle, and a square, and a circle, whatever it doesn't mean. But that is the center point will be the our centroid. Now, this part is clear right now. Yes, this part is clear. Or anyone who need to ask any question? Yes, tell me. Anyone who need to ask any question?
No, sir, it is clear.
Okay, that's correct. So let me explain this thing with the simple concept. So I have the raw data. This raw data is unlabeled. So I have the group of the apple. I have the some apples. I have the some strawberry, and I have the some pears. So in my basket, I have the apples, pears, and strawberry. By applying the clustering algorithm, I can make the cluster of these fruits into the three different cluster. One is C1, C2, C3. C1 is the cluster of the apple. So why I'm putting this uh, apple or all the apples in this cluster? Because based on the features, what are could be the features? Size and shape and colors could be. And next cluster we have the pairs. So in the pairs you can see the different colors we have, so different size we have, so we have the pairs. Next cluster or class we have the strawberry. So based on the our features, size and shape, or the different colors parameter, we can see this is our strawberry class or strawberry cluster. So this is the thing. But before applying the clustering algorithm, we don't know the x, y, z fruits will be the x, y, z class. We don't know. That's why it is under coming to the unlabeled data. So there is a big question student can ask, sir, what is the application of the clustering? Undoubtedly, there are lots of the application of the clustering. So I have the various applications. So I would like to introduce some applications over here before describing its types or sub flavor of the clustering. So clustering basically helps in the marketing persons to improve their customers. So if you remember the some simple example as a marketing manager person, so I just finding in a particular city there are some specified location where the some customer are demanding the XYZ product. So I will go again on the specific location or specific area because this product is more demanding, or most demanding of my banking product is more demanding in a specific area. So that would be the on this geographical area I can mark this is an area where I can see many customers or many people are dying to have this banking product. So I will like to visit such colony or such area, but I will not like to go to those area where this product are not applicable. So this is only the thing we have to keep in mind. So you will need to visit some society where this product is more applicable. But if you want to suppose I'm taking simple example. Suppose you want to you want to visit such places where the people are very poor. Then you are requested to them just please have this LIC or different kind of the insurance policies. Definitely they will deny. Very frankly speaking. Why? Because they are not able to uh, survive with the different things, or they are not able to handle the good volume of the money, and they are not good in terms of the financial. But you would like to visit some society or some posh area where the some rich persons are residing, so you can request to them just have this insurance. So you need to target the some people, and you are targeting the some area, you are targeting the some places. So you are doing the good marketing, and you are making the cluster because in the posh area and the good area, good colony, so good persons can have the insurance policy or different kind of the policies because they are good in terms of the financial, so they can purchase their product. So this is kind of the clustering you can make. That is the only reason, and this is the great example the many banking person are applying before this online specified online mode. So very marketing persons are visiting the door to door, and their marketing person are visiting some area. But now this is changed into the online mode. Next example, I can take the clustering the help in the different identification of the group of the houses. Yes, of course, you can see in the different society there are different kind of the flats are available. Flat type A, B, C. Suppose we have so A flat and B flat and C flat. This is the category I'm making. So A, B, C. These are the three kind of the size of the flat we have. So definitely we have the structure A, B, C type of flat will different from each other. A flat is larger than the B and B is larger than the C. So C is a lower kind of the flat we have. So we can make the group and we can make the group of the houses, duplex houses we can distinguish. So in a specific area, some duplex are constructed and some flats are constructed. So you can mark or you can identify this is a cluster of the flat and this is a cluster of the duplexes. So you can just define the thing based on the geographical locations. And clustering is used to study earthquake. It's very simple example I can take. This is the thing you can identify from the our coloring diagram. That is a color dropping diagram or graph by which you can see all over the world what are the various countries or what are the various locations where the earthquake may come regularly. And there are some places where the earthquake is not coming regularly, so that will be a little bit darkened. But the we are darking those area, those places where earthquake are coming regularly. So we can easily identify this is the area where earthquake is coming regularly. So we will not go there. We will go only those places where earthquake are not coming regularly. And some things we have to identify. So you can mark the you can identify area by putting the cluster and into the different form. Just darken color, that is a regular earthquake is coming and non-regular earthquake is coming. So you can put on the area and in between you can identify the other kind of the earthquake variety. So that is only point you can analyze in the thing. So this is the happening. So this is happening with the our real life situation. So these are the three different example I have put it over here in form of the marketing person and identify the group of the house in terms of the construction size. And something is we can use the earthquake. But other than this application, I have been imported some other application. Here we have the marketing. Marketing is the biggest area, biggest application in terms of the clustering we can use. But the before moving to the other application, I would like to tell something more. That is, the clustering is a type of the unsupervised learning, as we know, and basically analyzing the data points in cluster them based on the similarity and dissimilarity. So what is similarity we have, what is dissimilarity we have? So you have to identify some objects which are dissimilar so you can put into the other group. But you need to find the some data items or some objects which are which are having the similar feature. So you can put into the same basket. So similarity or dissimilarity you have to identify based on the features. Please keep in mind. Now come to the point of our application right now. The second one we have the biology. So in the biology, we can use the classification, we can make the group of the clusters into different species of the plants and animals. So definitely we know there are various kind of the species of the plants and animals are available in this world. So we can make the cluster. See, there's a difference between the ape and monkey. So these are the two different species of the animal we have. We have the different type of the animals. We can distinguish, we can make the cluster. So in the biological, we can define library. Library is a very beautiful example. You can understand in the library what we have. If I need to search a book of the machine learning, so where I will move? First, I will need to move into the library, and that library I will like to go to the section of the computer science. In the computer section science, I need to look at the subsection of the machine learning. So I can easily search out the many books which are friends to the machine learning only. So I can take any book. But if all books are mixed up, then it is very hard to find the machine learning book because this machine learning book may be the part of the electrical engineer or some different subject. Then how I can identify? So I will waste my time to search my book. But if it is making the cluster, if it is divided into the different two groups, so I can easily search the book. That is the only reason. Insurance, I have taken the example of the insurance and city planning. City planning, of course, it is a part of the our planning the city where a group of the houses are constructed. But truly speaking right now, I can take the name of the two cities where the this city are planned properly. One is Chandigarh, other is Mohali. So what we have in these two cities or these two area, Some locations are identified. These are the places which will be apply. We will construct the flat, and this is the area which we will construct the duplex, and this is the area where we will construct some bungalow or 4 BHK duplexes like this thing. So they have identified the different locations. It means they have made the different cluster to define the type of the house. And also the studies, I have already taken this example. So these are the other or the same kind of the other applications we can understand the where clustering will be applicable. So these are the our application. So till now, any doubt you have, so please you can ask. These are the some example I have taken, and we can say application. It is clear to all, or anyone who need to ask?
Clear, sir.
Anyone who need to ask any questions, so please you can ask. Okay. Should I move to the next slide?
Yes, sir.
Yes,
Okay,
sir.
good. So you must have a very big question, sir. You are talking about the now clustering. How clustering is different from the regression classification? So this slide will show the comparison points of the regression classification clustering. Regression is supervised learning, as we know, and outcomes would be the uncontinuous quantity, as we know. And the main purpose of the regression to forecast or predict the our information, and that is predict the or forecast the weather, and predict the price of the house, and predict the stock marketing example. So we have this example. And the algorithm, we have the linear regression, multiple linear regression. So we have this could be the good example. Polynomial regression is also good example. Classification is also part of the supervised learning, but output would be in form of the category. And the main purpose is to compute the classify the data or categorize the data. And in this case, we have our example. In this case, we have the example that is classify the emails in the spam and non-spam. Any other example like you can take, you can make the group of the two different type of the. So you're talking about the by classification. It means you're talking about the 2D classification. That is not 2D classification. And the next the example we have the logistic regression. If we're talking about the clustering, as we have discussed few seconds ago, clustering means this is unsupervised learning and assign a data to into the clusters. And the main purpose or the main aim to just make the cluster with the similar type of the items we have, and find all the transactions which are fraudulent in the nature. So we have the transactions, some transactions are failed, some transactions are fraudulent, and some transactions are non-fraudulent. So based on some parameter, we can easily identify what are the transactions which are fraudulent or non-fraudulent. In this case, we have the k-means. That is the point. So before discussing the k-means, we need to understand where k-means is lying. The k-means is a better example of better algorithm for the clustering. So once again, before moving to the k-means, let us understand where it is lying. So this is the point. So after understanding the clustering, what is meant by the clustering, let us look at the other points which are describing everything properly. And from this point, you have to open your eye and brain, and you have to think properly. So first type of the flavor of the clustering I'm putting over here, that is exclusive clustering. In exclusive clustering, an item that belongs to the exclusively to the one cluster only. Please keep in mind, I am speaking once again. In the exclusive clustering means such data item that should be belong to the only the one cluster. Look at this diagram in the screen. You can see there are three different clusters, which is represented by the yellow color, orange color, and violet color, and next one is the blue color. So you can easily observe over here, no data points are belong to the multiple or several cluster. If it is happening, then we can say it could be a different kind of cluster. But exclusive cluster means the such data point should be belong to the only the our that cluster only. Just simple example. I can't put the tomato into the potato. So we can't say, but tomato and potato are mixing in the both case, then there will be no logical. Logic we can say tomato totally is different from the potato, how based on the color and size and shape. That is only meaning. So tomato will be the only the one cluster only. This is simple example. Other example, we have the blue and pink, two different kind of the data points we have, and they are representing the different different colors, so they are put into the respectively colors only. Next one, we have the overlapping clustering. Overlapping clustering, we have see observe over here. Okay, just before speaking this one, exclusive clustering, we have the k-means. K-means clustering is a type of the exclusive clustering example. So if you need to understand what is the k-means and where it is lying, so it is lying inside the exclusive clustering. Next, we have the overlapping clustering. Some data points are not easily to identify in which cluster they belong to, if they belong to the both cluster or more than the both clusters or two clusters. So we can say such clusters, such data points, such kind of the clusters are formed into the overlapping cluster. So you can see in the diagram, I have just darkened by the yellow color from the pink and blue, from the pink and blue data points based cluster. So these data points are common to both clusters. So it means here something are overlapping. So here this kind of the clustering is known as the overlapping clustering. And here we have a very simple example, that is a fuzzy C-means algorithm. And fuzzy C-means algorithm is the best example of the overlapping clustering. So first we have seen the exclusive clustering, where we have to identify what is meant by the exclusive clustering. It means only the one cluster such data point belong to only. So that is our, what we can say, that is known as our exclusive clustering. Now we're talking about the overlapping clustering. In the overlapping clustering, we have the fuzzy C means is the best example, where any data point belong to the multiple or several clusters. So we can say this would be the example of the our overlapping clustering. Third one, we have a hierarchical clustering. Hierarchical clustering is very simple and it just totally describe the tree kind of the structure. Let me take the simple example. You can say, suppose I have the students group. Okay, I can write over here for a betterment. See, this is a student group. In the student group, I am just applying the gender feature. So there's a male student and there's a female student. So what I did, I just created the two sub clusters. Now in the male, what I'm just observing, I'm applying the another feature, that is age. So based on the age, some students, those who are less than 50 or greater than 50, so there I can come into the this kind of the groups. Same thing I have to apply at the female group. So here the female students who are less than 50 and who are greater than 50, so I can make the different cluster. So how many cluster I have? I have the one cluster, two cluster, three clusters, and four cluster finally. These are the subclusters we can say, and what are the two clusters, male and female, and these are our data point, that is student data point. From this point, you can say this kind of representation we are applying to solve our problem, and at a time we have the hierarchical cluster. So while implementing any algorithm, and computational speed and efficiency becomes a very important parameter for the end result. So which kind of the algorithm you have to use? You have to choose the thing appropriately and properly, which kind of the clustering you want to use. Now, these are the three kind of the clustering we have seen: hierarchical clustering, exclusive clustering, and what was the third one? Third one is our overlapping clustering. So we have seen these three kind of the clustering. This is known as the our flavor of the clustering. Now it is clear right now. Is it clear to all right now? These kind of three different flavor of the clustering is clear. Yes, tell me. Anyone who need to ask question? Or is it clear? These three kind of the clustering is clear or not?
Yes, sir, it's clear.
Yes, sir.
Okay, that's great. So now, as per our curriculum, we have a two type of the clustering. So what are those? Hierarchical clustering and partition clustering, and that is our topic name of our class. So before discussing the hierarchical clustering and partition clustering, we must understand what is meant by the clustering and where we are lying. So hierarchical clustering and partition clustering we have over here. So hierarchical clustering is also further divided into the two subparts. One is agglomerative clustering and divisive clustering. Agglomerative clustering means in the hierarchical clustering we have to use the approach bottom up approach. It means we will start our separation of the cluster or creating the cluster from the bottom to up. If we have a divisive clustering, so a divisive clustering is saying to us you have to apply the top-down approach to create your cluster from top to down. So such approach is known as the divisive clustering. In partition clustering, we have a two-part examples. One is a k-means clustering and fuzzy c-means clustering. And k-means clustering is an example of the exclusive clustering, and fuzzy c-means clustering is an example of the overlapping clustering. So I'm repeating once again: exclusive clustering, overlapping clustering, and hierarchical clustering is a basically a flavor of our clustering. And but as per our curriculum, what we have the two type of the clustering: partition clustering and hierarchical clustering. So hierarchical clustering we have seen by the two types. One is the agglomerative clustering and divisive clustering, while partition clustering is divided into two parts. Once again, we have the k-means clustering and fuzzy c-means clustering. So let us first talk about the hierarchical clustering. So when I'm talking about the hierarchical clustering, so what is mean by the hierarchical clustering? The overall, as we have seen, the hierarchical clustering means the tree-like representation we have to see. So suppose we have some data item which are consisted by the orange and apple. So how we can distinguish the two clusters which are represented by the apple cluster and orange cluster? So definitely we can see this example, this diagram or the image will depict our scenario in simple way. So this is a hierarchy clustering, as we have seen few minutes ago as well of the student example. But when talking about the agglomerative clustering and divisive clustering, that is a subtype of our hierarchical clustering. So you can see this diagram right now, and I can make this image in zoom mode so you can see. Look at this diagram. So in the agglomerative clustering, our agglomerative hierarchical clustering, what I have from bottom to up approach I have to follow. So A, B, C, D are the six different data items or some group of the data item we have, or mixed kind of the data item I have. So first I am making the cluster, that is cluster C1, that is A I have, and rest of the cluster will be the part of the B, C, D, E. So that is a cluster C2. Now I will divide the B, C, D into the bottom following by the bottom approach. So BC is the third cluster and DEF was the fourth cluster, that is the BC and DEF. Then I will divide the BC subcluster into the sub to subcluster, and this process will go into the iteratively. And now finally I will have the eight different or we can say the six different clusters A, B, C, D, E, F, and all these six clusters are represented by the six different data items we can say, or different data points, but all data points should be the similar. But talking about the divisive is nothing which is the, you can see over the screen, divisive is nothing, same approach we have to apply in the top to down approach. So we have the divisive hierarchical clustering. So ABCD is further divided into the our A, B, C, D, E, F groups or clusters we can say, but from the top to down approaches. And that is simplest example we can take over here. So this is the agglomerative clustering and divisive clustering inside the hierarchical clustering. Now these two clustering are clear under the hierarchical clustering. Tell me yes or no. Yes, tell me. Is it clear to all right now? Agglomerative clustering and divisive clustering.
Yes, sir. Clear.
Okay, great. Now, so what is the partitioning clustering? I have taken consider this partition clustering in little bit detailed manner over here. The reason is clear. Partition clustering is more popular clustering in anywhere, so that's why we have to use partition clustering for the practical purpose or for solving the numerical or for solving the real life problem as well. So K-means, Pam and Clara are the three different algorithms which enter come into the partition clustering. So K-means is what actually? And as you know, in the partition clustering, we have the k-means and fuzzy c-means. So before speaking to all the people, in the real life situation, Most of the people will love to work with the partition clustering, and we have the some algorithm which are famous in the partition clustering. Those are the k-means, PAM, and Clara. K-means means k is the number of total data points what we have. So what is the k? What is the means? I will tell you later on. But means we're talking about the we have to decide the centroid, and this means will play important role to update the my centroid. And rest of the thing I will tell you more about in the k means while discussing the k means algorithm. PAM, partition around madoid. So unlike the means, you can get the median. So when I'm getting the median, then such algorithm is known as a k-modoid, and this k-mod algorithm is also known as a PAM, that is a partition around madoid. So this is not in our syllabus, so we will not touch this algorithm in detailed manner, but we have to keep in mind this is an example of the partition clustering. Next one we have the Clara. Clara stands for the clustering large application. So instead of the k-means PAM, you want to use a Clara, then you can use. So these are the three different partition clustering we can use. But unlike the k-means, rather than the means can be used the median. Of course, you can use the median. So we have the k-medoid algorithm, and this is also known as the PAM. Unlike means and or median, can we determine the mode? Yes, we can calculate or we can determine, and that is example of the k-mode clustering. So k-mode clustering is also a type of the partition clustering. So unlike the k-means, we can evaluate the means, we can calculate the median, we can calculate the mode. So what kind of the statistic formula you want to use to determine the your cluster? So at the time, such kind of the algorithm is known as the k-means, k-mode, and k-median. So k-means and k-mode we will see in detailed manner along with our numerical as well as our theoretical. So this is the point you have to keep in mind. And now come to the point partition clustering. So partition clustering, as we know, partition clustering, we have the k-means clustering, and that is a type of the our exclusive clustering. So in the exclusive clustering, as I told you, no data point will be belong to the different group. It will be considered into the one class or one cluster only. So every any data point that is a class of the C1 or cluster of the C1, and that will not be the part of the cluster C2. So that's why we have the k-means clustering. When talking about the fuzzy C-means, in the fuzzy C-means there is no guarantee because this is the example of the overlapping clustering. Some or many data points may be the part of the several clusters. So this is the point. So here you can say C1, C2. So the other two clusters. So you can say in between we have the four data points. You can see observe over here. Four data points are the part of the C1 as well as the C2. So this is known as the overlapping cluster, and the example we have the fuzzy C-mean. So k-means and fuzzy C-means are the very beautiful examples, or in terms of the algorithm we have inside the partition clustering. Now, so this is just idea about the partition clustering. Is it clear to all? Once again, let me know. Is it clear to all? Just tell me. It is clear to all right now? Tell me anyone who need to ask any question. Yes, tell me anyone who have any doubts, so please you can ask.
No, sir, no doubt.
So what we have covered what is mean by the clustering, what are the applications of the clustering, and what is the type of the clustering, of course followed by the exclusive, overlapping, and hierarchical. In the hierarchical, we have seen the agglomerative and divisive, and partitioning we have seen the k-means and fuzzy c-means. So these are the our different type of the clustering algorithm we have seen. Now let us move to our important algorithm, that is the k-means clustering. That is the example of that. That is our part of our curriculum. So we will see that point right. K-means clustering is one of the simplest algorithm which uses unsupervised learning method to solve known clustering issues. And k-means clustering is required the following two inputs, of course, number of the clusters. K stands for the number of the cluster. But when the KNN algorithm, so I would like to say some more detail about the KNN over here. You can't mix the KNN and k-means. So in the exam time, I can ask the just differentiate k-means and k-NN algorithm. So just for your knowledge purpose, I can improve some words. K-NN is supervised learning and k-means is unsupervised learning. KNN, in this KNN, we have to use this problem for the classification problem, while K-means is especially used for the clustering problem. In the KNN, in the K stands for the number of the neighbor, while K-means K stands for the number of the clusters. So that is a little bit difference you have to keep in mind. So in the K-means algorithm and the K-means clustering, we have the K stands for the number of the clusters, and training set I will use. So x1 to xm. So total data points which are stands for the training data set we have to use. So what are the data points we are going to use? So we have to consider as x1 to the xm. So we have to use k, this one. So these 2 points we have to keep in mind while implementing or understanding the our K-means. And for explaining this algorithm, whatever I have right now, you will see after a few couple of seconds. Algorithm you can easily understand by the numerical portion. Algorithm you can easily understand by the numerical portion only. So here I have this picture by which you can easily say how and what we are saying. Now, K-means algorithm is also based on the Centroid. So here we have to keep in mind some important terms inside the K-means algorithm, but here we have an introductory part, theoretical point, what it is written over here. It is the most commonly used algorithm for the partitioning with the given data set and into a set of the key groups. K means number of the cluster, and where K represents the number of the groups. And it classifies the object in the multiple groups, that is clusters, and such that object within the same cluster as similar as possible. I am repeating my statement. If there are some objects which are belong to the same kind of the features, I am putting into the same cluster, and that is known as the our high intra-class similarity. And when some object which are put into a different group because based on the similar, and such kind of a cluster undercome into the low intra-class similarity. Potato and tomato are the two different kind of the group data item, and I'm putting into the two different kind of the cluster. So what I'm following the low interclass similarity. That is only point. But the some cluster I'm following, so those clusters also example of the high intra-class similarity. And high intra-class similarity and low intra-class similarity you can be identified into the overlapping clustering. But when you are following the exclusive clustering, no issue at that time. In K-means clustering, each cluster is represented by the center, and that is known as the centroid, and which correspond to the mean of the data points assigned to the cluster. And the basic idea behind the K-means clustering algorithm to consist of defining the cluster so that the total intra-cluster variation we can manage or we can minimize. Total intra-cluster variation, we can identify that how many high intra-class similarity we have or how many low intra-class similarity we have. So we can find the our total intra-class variation, and that should be minimum, or the variation should be minimized. So if it is we are having the variation minimized, so definitely we can easily say we are making the good cluster rather than saying the bad cluster. You can create the cluster, but there is no guarantee we have distinguished or we can put the correct data point into the correct cluster. But if you have the high variation, we have the high variation, so it means we can say we are not created the good clusters, but we have the minimum or minimum variation in the terms of the total cluster variation, so we can say we have the good cluster. So this is the point you have to understand. So K-means algorithm can also in the exam time just explain the centroid based technique. So you have to explain only the K-means algorithm, that is enough only. For your understanding purpose, what we have been observed in the theoretical point, this is also depicted by the flowchart. So we are starting, so we are taking this point. So first what I have to choose, I have to choose the number of the cluster, that is the point. And then I have to decide the center of the our cluster. And after deciding the center of the our object or our pool of the data point, from that point we have to evaluate the distance between the object to the center. So distance between all the object, all the data point to the center, and we have to say what is the minimum size of the data I'm getting over here, minimum distance, and finding that this distance based on the I have to make the group of the group. So I'm just defining the some range, and based on range, I have to create the some groups. And after defining the group, there will be no issue. But if I'm observing no object is moved into the any group and nothing group, no groups were constructed or no group is created so far, and then I have to apply this process again, and this is iterative process. This is iterative process. So overall, we can understand this diagram into theory point. So you can see observe over here into the this steps. I'm repeating once again, this is the most important steps involved in the K-means clustering. These steps which are highlighted by here, and some steps are written into some words are written into the red colors. Those are main important words, and that describes everything properly. So first step, when I'm using the K-means clustering algorithm to indicate the number of the cluster, and that will be generated in the final solution. So what is the first step? Is according to our diagram, what we have been observed, we have chosen the number of the K. And number of the K means number of the cluster. And this cluster, if I'm choosing, so we have not evaluated the initial label of centroid. So our initial centroid will be the any data point. You can choose any random data point that would be our initial data point, that is known as the Centroid data point. And from such a data point to that is Centroid data point, we have to calculate the distance. And if I'm choosing the random data point or some objects, and these objects are known as the cluster means or centroid. If these objects which are selected by as a centroid, and these are known as the cluster means or centroid. After this point, you have to calculate the distance, and you have to apply the formula of the equivalent distance. Then you can calculate distance between each and every object. Now, after this point, what you will do, you will defining the distance between the object and cluster means. And now this step is come into the clustering assignment steps. This cluster assignment step is more important, where you are just defining the distance, you are finding the distance, you are just evaluating distance between the actual data point or the object into the our equivalent distance. Next, after this point, there is a guarantee whatever the cluster you have chosen as a you have whatever data point you have chosen as a central data point. Is it guarantee, or there is a guarantee this centroid will be the correct centroid? So we can't say. So we will try to update this centroid. Maybe we can choose the center value in better way, and this is coming to the centroid update. So after assignment steps, the algorithm computes a new mean value. Here I'm talking about the new mean. In the K means, we have to determine the mean. And don't worry, here we have a numerical by which everything will be clear to all, how we are getting the thing and how we are choosing the centroid values. So after assignment steps, the algorithm computes the new mean value of each cluster, and the term that is known as the centroid update is used to design the step. And now the center have been recalculated. Now we have to again apply the equivalent distance formula to calculate the distance, and the distance will be updated. And every observation check again, see it might be closer or it is different the cluster. And the whatever the data point I'm choosing, there is a guarantee it is under coming to the correct part or not. If it is correct part, that no issue. But if it is not in the part of the correct, then we have to put into the another cluster. After this point, cluster assignment steps and center update steps are done repeatedly again to get our result properly. And this cluster assignment stop changing until we get the convergence is achieved. And this is our point. So for your understanding purpose, what I will do, I would like to tell this point right now. First, I would like to explain the thing very simple. Just tell me right now, are you able to see this blank screen?
Yes, sir.
Yes, sir.
Okay. See here, I am just we have a set of the data points. Here I am plotting some data points randomly. Suppose this is a data point, this is a data point. Randomly I am plotting, okay, just randomly data point. Very less data point I have taken over here, and some data point I have taken over here. So what is our steps? Our step is saying to us in the set of the data point, what is our steps? Our initial step is saying to us, to you people, you have to choose the as the initial label. You have to choose any data point as a randomly. Suppose I'm choosing this one. This one becomes my centroid. This one becomes my the centroid. Okay, this becomes my the centroid. So from the center to all the data points, I have to calculate the distance as I'm doing right now. And this distance will be calculated by the equivalent distance formula. Now this step is clear right now. This is centroid. We have chosen an initial label randomly, and then we have to determine the calculate. Now these are the two steps. While calculating the its distance, this is known as the centroid. This is known as the cluster assignment step. Now it is clear right now. I'm taking very graphical example. I hope it will be clear to all. Is it clear to all right now? Tell me yes or no. It is clear.
Yes, sir.
Okay, that's good. So here I'm plotting the all the data point position as it is. On the same location. So as per this point now, what I have been observed the important thing. This is very close to this point. This is close to this point. This is very close to this point, and this is close, and this is close, and we can say this could be the close, and these are the close. So I can make it in a group. So this could be the this point based on the some distance. We can make this group, and this would be the another clusters. Now it is clear right now. So I have made the two clusters. Do not think about the different colors. Initial level I have just choose a different of the data points that could be the same color. So now these are the our two clusters. This could be the C1 cluster and this would be the C2 cluster. Now is it clear right now? Just tell me, is it clear? These are the two clusters I have prepared right now based on the distance.
Yes, sir.
And
Yes, sir.
based on the distance and why this cluster is just I can explain here why this cluster the center to this distance we are under come into the this cluster. Why I'm choosing this cluster inside this cluster only, or this data point why I'm choosing in this cluster only based on the similarity feature. And here I'm just using the distance of I based on this I'm making a cluster. So based on the distance I can do. Now based on the distance I made the cluster. But this step is not step or stopped over here. Suppose I'm defining the k equal to 2. So it means I'm defining the cluster size 2. So I made the 2. Suppose I am defining the k equal to 3. So what I will do? Maybe. What it could be? Maybe this could be the one cluster. Suppose I'm defining k equal to 3. So this could be the one cluster. This could be the another cluster. Just I'm taking example only for understanding purpose only. And this could be the one cluster. So here I'm talking about the three different clusters because I'm used the equal to 3. So that is a point we have to keep in mind. So from this point, next step is saying to us. Next step is saying to us, you have to choose the again new centroid. Now, so from this, suppose this is a cluster 1 and this is a cluster 2. Right now I'm changing here. Now this is a cluster 3. So cluster 1 is again choosing the these are the two data points. So any one data point be our center. So this would be the centroid of the cluster 1. Tell me yes or no. Tell me. In this cluster, these two out of these data points, any data point I'm choosing here as a randomly, this will be centroid. Yes, tell me anything. Whatever you want to speak, tell me. And this could be the centroid I'm choosing here in the cluster. Initially, there was only the one cluster, so which contained all the data points. Next, I'm choosing this one is a centroid. Next, I'm choosing this one is centroid. So our iterative process will be applied, and after applying this point, again distance will be calculated. So distance from this to this one, and this one is calculated. Again, all the data points. So again, we find out from this data point to the this these are the two data points which are close to this centroid. So now these will be the part of the our cluster C1 could be. So again, every time your cluster size will be updated. Okay. So this will be the functionality of the our k-means clustering. K-means means you have to determine the means, and while choosing the centroid, you have to use the mean. So you can evaluate, you can calculate the, or you have chosen the centroid. That is a right. The cluster means and centroid you have to tell me, you have to determine, then you have to evaluate the equivalent distance and then centroid update and cluster assignment and centroid update process. Same thing we will see inside the numerical portion. So this algorithm will be more clear while understanding the numerical portion. So before understanding the numerical portion, I am just taking only the simple step by which you are able to see. So this was our example. Is it clear right now? So don't think about right now very hardly. Just focus on the concept only, and very truly speaking, we can see its numerical, then everything will be clear to us. So introductory part of this k-means clustering is clear. What is centroid and what is a cluster, and how we can determine the number of the clusters.
Sir,
Hmm.
sir, how are we choosing a centroid? So can you please explain that again?
Yes. I can explain this thing by once again very simple, by taking a simple example. Just look at this one right now. As an initial label, some data points are given. These are some data points. Now clear right now? Tell me yes or no. These are center data points.
Yes, sir.
So as an initial label, you can choose any data point as a randomly. So here I am choosing that this would be my centroid as an initial label. This would be my centroid. Now clear?
Yes, sir.
Okay, so now what I will do as an initial level from this center to from all the data points, I have to calculate the distance. Now, as you can see, just look at my diagram. I'm just determining the distance. Now, clear right now?
Yes, sir.
So now after this point, based on distance, so from this data point to these data points, you can see by the different color. Now let me explain right now. So after calculating distance, now after choosing this centroid, I've been observed over here. These are the data points. These are the some data points which are close to the my centroid and others are not. These are not. If I'm choosing the k equal to 2, I can make the two groups. This would be the cluster C1 and this would be the cluster C2 out of the our entire data. Now it is clear right now?
Yes, sir.
Now after this point, what we have to do? Next step is saying to us what you have to do. I can explain over here. Just yeah. So from the cluster C1 and cluster C2, it is a iterative process. From cluster C1 and cluster C2, you have to choose any random cluster. But now this is the time we can't choose a random cluster because as per the mean, as per the means you have to use. So by evaluating the or by calculating the mean of the all these values by the numerical value or by the numerical problem, I will tell you how to calculate the mean of such point. We will choose the centered value, and suppose this will be chosen as a centered. So what we'll do, this was our previous centered will be discarded and this will be the my new centered. and this would be my new centroid, and this is known as centroid updation. So now this becomes the centroid. Same thing I will apply over here, and suppose this becomes the centroid. So this becomes our centroid. Now from this, from the each and every centroid in the each and every cluster, we have to use the our equilibrium distance formula to calculate distance. Now from this one, okay, and from this to this one, and this one, and this one, and this one. But I have been observed over here. I can explain over here. Just look at this point. From this data point to, which is marking by a circle, from this data point to this data point is suppose is closer. Suppose closer. So this data point will be the part of this cluster. So now this is what this is known as the updating centroid as well as the updating the cluster size. So now this will be the part of the work. So now my new cluster form will be like this one. Now clear? So my new cluster will be form size of the new cluster. Now it is clear right now?
Yes, sir.
And this is a iterative process, and it will be happen many times, and it is depend on the number of the cluster, how many number of the cluster I want to form. And this we will see by the numerically in detail way. So everything will be clear to all. And I'm repeating once again, this is iterative process, and it will take much time for the computation. But at least we can have some guarantee we are going to the right direction and we are getting the good cluster size or good clusters. And that's why the k-means is more popular. Now what we are doing, we are applying the partitioning. We are applying the partitioning, and one thing, if this cluster becomes the part of the such cluster, then it will not be part of the another cluster. So what I'm following the exclusive partitioning. I'm following the exclusive clustering. That is the meaning. So theory, this is the point. Theory point is clear right now. And numerical point, at my promise, we will discuss in our next class with a numerical way. But theory portion should be clear, and how this algorithm will work and how this algorithm is working. Now it is clear to all right now. Yes, Tammy. Is it clear to all right now? Okay. So here I have very simple video to all the people, and you can see such video where everything will be clear with the animated way. So just look at this video. I would like to play this video with a little bit sound, then you can easily see. Okay, the video is available on the PPT, so I would like to continue with the PPT as well. Okay, this is visible to all right now. The k-means cluster. Okay. And look at this example. So as initialization, what I have randomly selected the cluster. So you can see different colors. You can see the different colors. Say just magenta color, yellow color, and pink color, and some dark yellow color. We have the different cluster as initial level at the different groups. So randomly selected the center. Now just while watching this video as a tutorial video, you can say just also read the some points what we are doing as per the algorithm. Iteration number 1, assign data to Centroid. And this iterative process, now updates are centered, so some centroids are moving. Just look at the marked data points. Just look at the color of the data points. Assign data to Centroid, again this is a iterative process 4. And then update Centroid, and this iterative process, it will go on again. Now result upon. So what you have been observed initially, the marked data points which are marked by me here, now it is represented by the sky blue color present color. Now previously it was in the pink color. So that was our simple example. So now this is a simple tutorial by which you can say how the cluster algorithm will work, because it is a iterative process. So tell me right now, it is clear to all right now? The K-means algorithm is clear right now, and numerical portion we will see in the next class. But before that, the theory portion should be clear. Is it clear to all right now?